Here are 3 points to plot, so go ahead and sketch out a polar axis and try plotting them. I'm using millimeters here, but the exact units for radius, but the exact units don't really matter. And so plot them and then come back. All right, so for A, we're looking at an angle of 3 pi over 2, or 3/2 pi, you could say. Remember that we're usually doing r listed first and theta listed second. The giveaway for theta is that it usually involves pi, right? So what angle is 3 pi over 2? That's starting here, going around 3/4 of a circle. So starting here, going around 3/4 of a circle, and then going 20 millimeters out from the origin. So we could say that's point A, where this distance is 20. Then how about point B? Well, our angle now is negative pi over 4. So instead of going counterclockwise like we usually do, we're going to go clockwise. Pi over 4 is 45 degrees, but it's negative, so we're going down here below the axis and then going out 10 units. So 10 millimeters there. So that's B. And then how about C? This one gets tricky. We're going 3 pi over 2, so we're going 270 degrees around, you could say. But then, how many millimeters are we going in that direction? We are going -8 millimeters, so we're actually going up this way. So something at around 8 millimeters, going the opposite way of the ray that we just found the direction of. So polar coordinates can be a little counterintuitive that way, that you can use negative radii, which has never been allowed before, right? You can use negative angles, which we're kind of used to, but we don't usually think about too much in calculus class. But based on these ideas, what can we do to give other representations of these same points? Like here, we went 3/4 of the way around a circle. Is there kind of a more efficient way to get to that point? Not that we're really worried about efficiency, but is there another way to designate this point here? Well, its radius would maybe still be 20, but you could say, hey, let's use a negative angle, like a -90 degree, which would be negative pi over 2. So you could say 20 comma negative pi over 2. Negative pi over 2 would say I'm starting pointing that way, and then I'm turning the opposite of my usual way, and then going out 20. Or, if we like their negative radius idea, we could say I'm going to start here, turn 90 degrees the usual way, pi over 2, and then go backwards 20. So we could say backwards 20 after pointing in the pi over 2 direction. How about B? Can you say other ways to represent B? Well, here we went we actually went not most of the way around the circle, we went backwards a little bit. So you could say, let's go most of the way around the circle instead. So you could say, still a radius of 10, but instead of going backwards 45 degrees, I want to go almost all the way around, which would be 7 pi over 4. You see how if it was 8 pi over 4, that would be 2 pi, which would be all the way around the circle. Or you could go, what would that be? 90 degrees plus another 45, which would be 135, which would be what? 3 pi over 4. So go around this way, be pointing out that way, and then go -10 based on that direction. So that's 3 ways of writing that point. Then how about point C? You could go 90 degrees, pi over 2 upward, and then just 8 millimeters out. So pi over 2. And I think we won't be even more ridiculous there. Actually, let's be a little more ridiculous. So there we tried going 3/4 of the way around then backwards. We tried going just 90 degrees and then forward. We could do turn 90 degrees, and then turn another full 360, and then go 8. So that would be 2 pi plus the pi over 2 we had there. So we can do angle measurements more than 360 or more than 2 pi here, and that's still perfectly allowable.